You'd think those cars have to go crazy fast to pull off that loop, right? But what if I told you that the actual speed they'd have to go at minimum is probably lower than you'd expect, and I can prove it with physics. And the main thing working against these cars is gravity. It's constantly pulling them down. But because they're moving in a loop, in a circle, they're also experiencing something called centripetal force, which keeps them pressed against the track. For the driver, it actually feels like they're being pushed into their seats the whole time, even when they're upside down. And that's because of a force called the centrifugal force. Technically, it's a pseudo-force, but let's not overcomplicate things. To avoid falling, the force pushing the car into the track, the centripetal force, has to be at least equal to gravity pulling it down. That gives us this equation. And thankfully, the mass cancels out, meaning it doesn't matter how heavy the car is, only the radius of the loop and gravity matter. The loops in the X Games stunt were 66 feet tall, meaning a radius of 33 feet, or 10 meters in the better unit system. Plugging that into our equation, the minimum speed of the cars needed to stay on the track was just 9.8 meters per second, or about 35 kilometers per hour. That means that this loop could have been done in a school zone, and the drivers wouldn't need to go a single kilometer over the speed limit, and it would still work. That is way slower than what we usually expect from stunt driving. And that's why people in the comments of this video are saying it looks slow. But in reality, the drivers are going way faster than that for safety, because it just barely making it would be a terrible idea. So next time you see a loop stunt, you can impress your friends with the physics behind it.